everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of chemistry, that is solutions. So let's begin with the chapter. Mixture. What is mixture? Mixture is referred to those substances which consist of two or more elements or compounds mixed together in any ratio and does not give rise to a new compound. For example, seawater, air, chocolate milk, etc. There are two types of mixture, homogeneous mixture and heterogeneous mixture. Homogeneous mixture has only one phase, they have the same composition throughout and there is no visible separation of line between the constituents. For example, sugar solution and vinegar. Heterogeneous mixture which has more than one phase is known as heterogeneous mixture, and there is a visible boundary of separation between the components and they do not have the same composition throughout. Homogeneous mixture of three types: solid homogeneous mixture, that are alloys; liquid homogeneous mixture, that is solution of alcohol in water; and gaseous mixture homogeneous mixture, that is the air. Heterogeneous mixture are of three types: solid, that is mixture of sand and sugar; solid liquid, that is solution of chalk and water; and third, gaseous mixture, that is smoke and air. Substance cannot be separated into its constituent particle by any physical process. In solution, the component of the solution that dissolves the other component in it is called solvent, and the component of the solution that is dissolved in the solvent is called as solute. Property of solution that they are homogeneous, the particles are extremely small, not visible to naked eye; light path not visible; solute particles cannot be separated by filtration. Then what is solubility? Solubility of a substance is the maximum amount of the substance that can be dissolved in the specific amount of solvent at specified temperature. Effect of temperature, that is Le-Chatelier's principle, says that when the dissolution process is endothermic, the solubility will increase with increase in temperature, and when the dissolution process is exothermic, the solution will decrease with increase in temperature. Pressure does not affect solubility. Henry's law states that the solubility of the gas in a liquid is directly proportional to the pressure of the gas, or the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution, that is P equals to Kh chi. Kh is the Henry's constant. Application of Henry's law: solubility of carbon dioxide in soft drinks and soda water is increased by sealing the bottle under high pressure. At high pressure underwater, scuba divers have to cope up with high concentration of dissolved gases with breathing air. At high altitude, climbers become weak and are unable to think clearly, which are symptoms of a condition called anoxia. With increase in temperature, the solubility of gas in liquid decreases. Raoult's law: for a solution of a volatile liquid, the partial vapor pressure of each component in the solution is directly proportional to its mole fraction. Ideal solutions are solutions which obey Raoult's law over the large entire range of concentration, and non-ideal solutions which do not obey Raoult's law. Positive deviation from Raoult's law: vapor pressure of the solution is higher than the predicted by Raoult's law. Solute-solvent interaction are weaker than solute-solute and solvent-solvent interaction. There is a negative deviation from Raoult's law: the vapor pressure of the solution is lower than the predicted by the Raoult's law, and the solute-solute and solvent-solvent interactions are weaker than solute-solvent interactions. Colligative properties and determination of polar mass: RLVP, that is relative lowering of vapor pressure, is equal to the mole fraction of the solute, that is P1 naught minus P1 upon P1 naught equals to chi 2, and chi 2 is equal to N2 upon N1 plus N2. Yani P1 naught minus P1 upon P1 naught is equals to N2 upon N1 plus N2. Elevation of boiling point: delta TB is equals to TB minus TB naught, that is equals to elevation of boiling point, where TB is the boiling of the solution, TB naught is the boiling point of the solution. and delta TB is directly proportional to M. That is, delta TB is equals to Kb into M, where M is the molality and Kb is the proportionality constant known as boiling point elevation constant or molar elevation constant or ubuloscopic constant. Depression of freezing point. Here delta TF equals to TF naught minus TF, that is equals to depression of freezing point, where TF naught is the freezing point of solvent and TF is equals to freezing point of solution. For dilute solution, delta TF is equals to Kf into M, where Kf is the cryoscopic constant or molar depression constant or freezing point constant. Kb is equals to R into M1 into Tb whole square upon 1000 into delta H of vaporization, and Kf is equals to R into M1 into Tf square and upon 1000 into delta H of fusion. Osmosis and osmotic pressure. Pi is equals to CRT or pi is equals to N2 upon VRT. If two solutions have the same osmotic pressure at the given temperature, then the solutions are called isotonic solution, and the abnormal molar mass lower or higher than the expected or normal value. Van't Hoff factors I expresses the quantitative extent to which a solute is dissociated or associated. And these are the modifications of equations for colligative properties. Thank you for watching my video. Hope you liked it and understood it. Thank you.